Hello and welcome to the introduction to this section, which is the Postgres CRUD operations. CRUD basically is an acronym for create, read, update, and delete. A lot of the times, the operations you will perform on a Postgres database will be to create, to read, to update, and to delete. You also obviously need to add records, and you do that with the insert command as well. But CRUD stands for create, read, update, and delete. So we'll be performing these operations in this section. Thanks for watching. Hello and welcome to this lecture. In this lecture, you'll learn how to create a database using the PG4 admin tool. To access the admin tool, you need to go to All Programs if you're on a Windows and locate the Postgres folder. If you expand that, the PGAdmin4 tool is located inside that folder. So click to launch the tool. Give it a few minutes to launch. When the admin tool loads up, just click to expand the servers and click on the Postgres server. Once you click on that, it will give you an option to log in. So if you can just enter the password that you entered during the installation of the Postgres server. Click OK. And it should give you access. It tells you server connected on the bottom right. So now to create a database, we just right click on this databases folder here and click on create and then database. It should give you a dialog box to enter some details. You need to enter the database name. I'm going to call mine fruits. And you can put a comment if you want. I'm just going to say database of fruits. And that's basically it. If you click save, it should create the database. Give it a few minutes. So the database has been created. That's the database here. When you create a database, it jumps to the top. So that's the database we've just created. So click on the plus sign to expand it so you can see more about the database. So these are all the objects that come with the database. This is a schema. If I expand that, it creates it under the public schema. And it also creates other stuff. So these are other objects that are created when you create a new database. So we can check on the properties by clicking on this property icon there to see what the properties are. And this is basically the properties of the database. So when you create a database, by default, there's certain things you enter. Others can be completed for you. Like these here grayed out, there's the security option here. So none of that was completed. The definition was inserted for you. This is the encoding. By default, it gives you this table space. Collation indicates the language you're using. So I'm in the UK, so it's put that there. Template, it says no, I'm not using any template. Allow connections, yes. You can also decide not to allow a connection if you create a database and you just want to use it for testing purposes and you don't want any connection while you are doing some tests. Other things you can check, click on the SQL to see this is the SQL that was actually generated when you create a database. So if I was to create a database using SQL or SQL, this is how I would create it. From the information I provided, it has generated a SQL for the database. So this is the SQL used to create the database. Click on statistics. There shouldn't be that much. So these are various statistics relating to the database. Dependencies, there shouldn't be. Dependents, there's no dependents. So you can also access the property page by right-clicking on the database itself and going properties. Once you're in the properties, you can also click on the definition. This was the only information we completed during the creation of the database. The definition part was actually inserted for us by this tool. So all this here, we didn't do it. The tool inserted it for us automatically. And security, if at some point you want to implement security on the database, this is where you implement the security. So you have to be a guarantor to add privileges, and then this is where you grant the users. Parameters, if you've got any parameters, this is where you add it. Default privileges, if there's any, this is where it will be. And the SQL here tells you nothing has changed from the SQL that was used to generate, or the SQL that was generated when the database was created. So that's basically how you create a database using the PGAdmin4 tool. Many thanks and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to create a table using PG4admin. Open up your PGAdmin4 tool. I've already opened mine and I'm already logged into the server. So to create a table, there must be a database already in presence. So you create a table inside a database. So the database I'm going to create a table on is this database called Fruits. We created this database earlier. So I'm just going to expand this database and look for the schema. This is a schema. Inside the schema, which is called public, there are tables. Although there's no tables at the moment, but this is where you create tables from. So to create a table, you right click on tables, which is under this Fruits database, and click on create and then table. And it should give you an option to enter the table name. So I'm going to call my table oranges. And it tells you the owner is Postgres, the schema is public. You can select a table space if you want. Once you've done, just click save and it should create the table name. So you can see here, that's the table oranges. We've now created a table. So we can go back to the table, right click and go properties, and we can add more bits to the table. We can add columns. So to add columns, we click on that. And before we do that, let me click on the general tab. You can see it's created it in the default PD underscore default table space. So let's go to columns and let's start adding the tables, the columns. It gives you option to, you can inherit from tables. If you've got other tables, you can inherit columns from tables. Gives you that option, but I'm not going to do that. I'm going to create new columns. So click on this plus sign here to create a column. So with tables, they store data in columns and rows. So I'm going to call this category ID, and I'm going to select the data type, which it has to be an integer because it's going to be a number. So I'll select integer, leave this to blank, and I'll select, do I want it to accept null value? No, I want there to be a value, so I say yes. Do I want to make it a primary key? Yes, I want it to be the primary key. So this column here all the records in this column will be unique. So that is the first column. So I click to save it, and I can add more columns. I go back, go into properties, I wait for it to load, and then I go to columns again, and I click on the plus sign, give me another row. So this time I'm going to add the name, and I'm going to make the character varying character. So I'll type in character varying, so it'll be a varying character. And you can give it a length. I'm going to give it 25 for the name. I don't expect there will be any fruit that will have more than 25 characters of name. Again, I want there to be a name. I don't want that value to be empty, so I say yes. I want it to be a null value. I don't want any null value. Null means there is no, you don't know. So, but by making this yes is forcing you to enter a name for the category. So I click save. I'm going to add one more. I go right click again, I go properties, wait for it to load, and I'm go columns, and click on the plus sign. I'm going to make this color. So I want to find out the color of the fruits. Again, I'll make this varying, character varying. I make it 25 as well. I'll leave this. So this can be empty if you're not sure what color the fruit is. So I don't want to enforce that. So I'll leave that option open. So if people are not sure what color it is, I want that left blank or null. I'll click save. So we've now created a table with 3 columns. If I expand this, you can see the columns of the table. So these are the columns. It tells you here 3 column. There are other things you can apply to the table. If I go on the properties, for example, you can you can apply constraints. You notice because I've added a primary key to one of the table, it's made that a constraint. Constraint basically in a way is kind of like a check. It forces you, it means you can't progress unless you enter something in that field. Okay, so there are other options here: advanced parameters, security. You can add security to a table, so you can give access or restrict access. If you want to do that, this is the area you will be doing that. And the SQL basically tells you nothing has changed since the table was created. So if you want to see the SQL that was used to create the table, all you need to do, let me cancel out of this. I click save. So if you want to see the SQL or the SQL, you right click on the name of the table, and where it's got scripts, just click on create, and that will generate a script with the create command. So there you go. So this is the script that you would use if you were to create it without, that is not with the table, not from within the admin tool. So this basically is the SQL or the script used to, this script was generated when you created the table. So if I wasn't going to use the admin tool, I wanted to use SQL or SQL, this would be the SQL I would use to create the table. So that's it for this lecture on creating a table using the PG4 admin tool. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres create table statement to create a table in a database. Let's take a look at a typical syntax to create a table. So this is what a typical syntax looks like to create a table. You begin with the create table command, followed by the name of the table, and then in between the parentheses you specify the names of the columns the table will contain. A table can have as many columns as you wish to specify. So once you specify the name of the table, you then begin to define or specify the names of the column. So you start with a column name, followed by the data type, if it's going to be an integer, which is a number, or a text. And there are different types of textual data type. So you need to insert that. And then if you want a constraint on the column, you also need to add that. A constraint basically is a condition that you apply to a column. For example, you can add to a column that you don't want that column to be empty. There must be a value. That is a kind of constraint. So let's go over to our PG4 admin editor and create a table. I have already logged into the PG4 admin tool, so I'm just going to expand the list of databases. When you're creating a table, you need to create it in the correct database and schema. So I've got 3 databases listed here. The database I want to create a table on is this one here called fruits. So I'm going to expand that and then expand the schema, and you should see one for tables. There's only one table there. So what I need to do, I need to access the query editor. So I right click and go query tool. You can also access the query tool from the tools option and click on query tool. So I have now got my query tool open. So this is where I'm going to define my table. As you can see here in the editor, it says fruits on Postgres. So it knows that I am in the fruits database, which is this database here. So that's where I'm creating the table in. So I'll start with the create table command. Followed by the name I want to call the table. I'll call it berries, and then I have to enclose parentheses, and then I put my mouse in between the parentheses and expand it. So in between this parentheses is where I'll define the columns for the table. So the first column I'm going to define is going to be the ID. So I'm going to type in berry underscore ID. I'm going to make that the primary key. A primary key basically is a column or a group of columns that is used to identify a row that is unique in a table. If you are adding more columns, you put a comma at the end of the first column, and then you tab to the next line and then add another column. So I'm going to type in berry underscore name. Again, I need to specify the data type this time. It's going to be a voucher data type that will accept, that can allow 255 characters. And I'm going to set a constraint. A constraint basically means that you are applying some kind of restriction or a rule to that column. What not means that there must be a value in this column. That is, it cannot be empty. For illustration purposes, I'm just going to leave it with 2 columns. But you get the idea. You can add as many columns as you wish to in a table. But for this table, I'm just going to make it really simple and just leave it at 2 columns. So I want it to be a 2-column table for now. Once you're done, you need to put a semicolon at the end to indicate that you are done with creating the table. You can always add columns later when the table has been created. Once you're done, you can now execute the query to create the table by clicking on this here. So once you've executed, it tells you that query returns successful. So successfully created the table. It tells you the command you used. Notice that I've added a data type. You must always have a data type when you're creating a column, so that the column knows what type of data to expect. So here, after the name of the column, you need to add the data type. This is an ID column, which is going to be an integer, which is a number. So this int means integer. So that's the data type for this column. So basically, this is a simple format that you can use to create a table. You can make it as simple as this one or as complex, whereby you can also add a constraint to several columns within a table, or you can also add constraint to the table itself. So let's quickly query this table that we've just created to see if we can communicate with it. So I'm going to quickly write a select statement. I'll do select star from berries. It's very important to always just check what you've done, just to make sure everything checks out. Okay, so I'm highlighting that and I click. So you can see it's successful. It tells you we've got 2 columns in this table, tells you the data type, but there is no data inside the table. So we've got the table structure all in place, waiting for data input. Thank you for watching, and I hope the lecture has been useful. So this is how you create a table using Postgres create table command. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'll be introducing you to Postgres select statement. One of the most common tasks you will perform when working with Postgres is the task of querying data from tables, and you do that by using a select statement. So the select statement is basically used to query data from a table. The select statement can be very basic, or you can make it complex by combining it with several clauses. So you can use it in combination with other clauses to make the select statement more complex and powerful. There are several ways you can build a select statement, but let's have a look at the basic syntax you can use. A syntax basically refers to how something is written. So for a very basic syntax or a very basic select statement, you can specify the column. For example, a table stores data in columns and rows, just like in an Excel spreadsheet. If you wanted to query data from a table, you have an option. Rather than query all the data, you may want specific data to query. So you can do that by selecting the columns individually and specifying the table where the data is coming from. And the way you will write that statement is this. You do a select, which is a select keyword. Select indicates you are trying to retrieve data. Select doesn't cause any damage to the database. There's no risk because all you're trying to do is read data. So you start with the keyword select, followed by the columns you want to retrieve data from. Say you have a table that has maybe 20 columns and you only want to retrieve data for 2 columns. Rather than retrieve everything and then sift through what you want, you can specify the actual columns you want to retrieve data from. This also helps save network traffic. Rather than pulling all the data from a table, you only pull down the specific data you need. So you assume you want to retrieve data from column 1 and column 2 from a table that has 20 columns. So you just specify column 1 and then you separate each column by a comma. Okay, so I want to retrieve data from column 1, comma, and then column 2. You don't need to put a comma at the last column because there's only 2. If you were to add another column, then yes, you put a column after the 2, but not with the last column. And then you need the from. The from is very important because the query needs to know where it's pulling that data from. So the from is used to specify the name of the table. The other way you can write a select statement is if you wanted to retrieve all the data from a table. So you want all the columns and all the rows. You don't want to be specific. You just want to get everything out of that table. The way you specify that statement is this. You do a select keyword followed by the asterisk symbol. That asterisk symbols indicates that you want to retrieve all the data from all the columns and all the rows. You also have to specify a from field, which indicates the name of the table the data is coming from. So these are the 2 basic ways you can write a select statement. These are just basic. You can obviously make it more complex by adding other clauses to it. But at the very basic, this is what a select statement looks like. This is how you would write it. You can also obviously make the select statement more complex by adding things, other keywords or clauses to make the query more complex. But in a very basic select statement, this is how you would specify it. So that is it for this lecture. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn to use subquery to build complex SQL queries. A subquery basically is a query nested inside another query, and this can be with a select statement, an update statement, and also an insert statement. To construct a subquery, the second query is placed inside brackets, and also you have the where clause used as an expression in the subquery. So a subquery basically is an SQL statement that has another SQL statement embedded in the where or in the having clause. So let's look at a typical syntax. This is what the syntax will look like. So this portion here where you've got the brackets, that's this bracket here and this one here in between, this is known as the inner query. So this here is the embedded query. It is known as the inner query, while this portion here, this part of the query here, is known as the outer query. So I've changed the color to make it more pronounced. So the part in yellow here is known as the outer query, while the query in green, which has brackets around it is known as the inner query. All right, let's start with a very simple example. So I've got a simple query here where I'm selecting the rental rate from this film. This is the film table, and this is the column I'm selecting, and I'm applying a AVG, which is an aggregate function, to this column here called rental rate, which is this column there. So suppose we want to find the films whose rental rate is higher than the average rental rate. So we can do this in two steps. First, we find the average rental rate by using the select statement and the average function, which I've specified here. The second step is to use the result from the first query in the second select statement to find the films that we want. So let's execute this so we can see the result. All right, so let me just expand that a bit. So this is the result from this query. So approximately is 2.98. So which means the average rental rate is 2.98. Now we can get the films whose rental rate is higher than the average rental rate. So I've implemented this query here. This query you can see to find the films whose rental rate is higher than the average rental rate. You can see here I've used the greater than sign. So I've said select the film ID, title, and rental rate from this film table where the rental rate is higher than 2.98. 2.98 was the average we found. So let me run this so we can see what it outputs. So this is the output from this query. You can see these are the rental rates. The way the code is implemented at the moment is not that elegant. So what we can do, we can make it elegant in two steps, and we'll do that by implementing a sub query. So what we want to do, we want a way to pass the result of the first query to the second query in one query using a sub query. So I've modified the query here to make it look more elegant, and if implemented a subquery. So a subquery basically is a query nested inside another query. So what I've done here, I've started with the select statement and picked out the columns from the film table. And in the where clause, I've applied some conditions. So I've said where the rental rate is greater. Okay, so it will output this result first and use that result of this first query and use it for the second query. So where rental rate is greater, and then this is where the second query starts from. So this is select, and I've applied an AVG to the rental rate from the film. So the second query is nested inside the first. You can see the brackets, that's the opening brackets, and that's the closing brackets. So the query inside the bracket is what is called a subquery or an inner query. The query that contains the subquery is known as the outer query. Postgres executes the query that contains a subquery in the following sequence. First, it executes the subquery, okay, which is this query here. Second, it gets the results and then pass it to the outer query. Third, it executes the outer query. So the format in which Postgres executes, first of all, it will execute the subquery, all right, which is the inner query, the query that contains the query in the brackets. This is the bracket here. So this query here is what is known as the subquery or inner query, while this here is known as the outer query. That is the query that contains the subquery. So when the code executes, it will execute the subquery first, which is this query. And once that query is executed, it will use the result from this query and pass it on to this outer query here. And the third, then the outer query uses that result and executes it. So let me execute so you can see. All right, so this is what the output looks like. A subquery can also return 0 or more rows. So this is just a simple illustration of how to implement a subquery. You can also use other operators when you are implementing subqueries. For example, you can use the subquery with an in operator and also with an exist operator. Many thanks for watching. I hope it has been useful. Please do let me know if you have any questions. Thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres update statement to update existing data in a table. Let's have a look at a typical syntax. So this is what the syntax will look like to update data in a table. So you start with the update keyword, followed by the name of the table. Then you use the set keyword. This set is important because this is what activates the change. So you type in the word set, followed by the column name you're trying to make the change on. Then you use the equals to sign. This equals to basically is what you use to change the value. So after the column name, you set the new value. If you're changing more than one column, then you separate the first column with a comma, and then you do the same for the second column. If you're adding more than two columns, again a comma, and so on. And then you specify a where condition. The where is important. The where acts as a filter to prevent you from updating any other records in the table. So the condition you specify in the where clause is important because that enables that only the columns that match the condition in the where clause will be updated. So let's see how this works. I've logged into the PG4 admin, and the database I'm going to use to illustrate is a database called Fruits, and it's inside the public schema. And the table I'm going to update is this table here called berries. So I'm going to right click on the berries table. One advantage of using this PG4 tool, it makes things a lot easier for you. So rather than me writing the script from scratch, I can just go here where it says script and select update, and it will begin writing some of these scripts for me. All I need to do is just make some modifications. So basically this is what it's done. It's saying this is the update statement. The public refers to the schema. Berries refers to the name of the table. So this is what I'm doing, is asking me what am I changing. So set here is what I need to specify what data I'm changing. So this indicates the name of the column. So I am going to, before you make any modification to a table, it's always best to see what the table contains first. So I'm going to do a quick select statement. Do a select star from berries. Where you've got more than one statement in the editor, it's best to highlight what you're trying to execute so that the editor doesn't get confused. That's one of the reasons you should always have a semicolon after each statement. Notice I have an error and the editor puts a dot where it thinks I've got the error. That's because I've got the name of my table wrong. So I missed out an extra R. So I just type that in and I'll run the query again. All right, so this is the content of the table I'm trying to make some updates on. And when you are making update, the process is the same, whether you're making updates to one or several columns in a table. All right, say I want to make some modification to this here called strawberries. I want to change the name of the strawberry. I want to add some extra text. I just want to add strawberries and then followed by the word UK, just to indicate that the strawberries come from UK. So the way I would do that is in the set area, I will get rid of the ID because I'm not changing the ID. What I'm changing is the name. Okay, so I'm going to say set berry name. That's the name of this column. I'm going to set it, and then I need an equals to sign to indicate the new value I'm going to give it. I'm going to call it strawberries UK. So I've added the word UK next to the strawberries. If I was to do that if I didn't include this where clause here, what that will do, it will update all the strawberry, everything here will update this to strawberries UK, that to strawberries UK, and this to strawberries UK. The where clause prevents that happening. This is very important because if you're in a production environment and you have thousands of records, if you don't include the where condition, it will just update everything, and that could be disastrous. So the where clause is very important. So I've used the set keyword to indicate where I want to make the change. So I'm changing the berry name, which is this here, to strawberries UK. In the where condition is where I need to attach the condition. So I will now say where berry underscore ID is equals to 1. So what that means, it will only change or update the records where this condition is true. You can see here the berry ID here is 1. So that means if I run this script, it will not affect the other records. So let's give that a go. I just select that and click on this to execute. If all goes well, it tells you query returned successfully. If I run this select statement again, you'll notice the change has been made. You can see now it's now updated this to strawberries UK. So that's how you perform an update statement on a table. The process is the same whether you are updating one record or 1,000 records. The key thing to take away here, you must not forget to include the where clause. If you don't include the where clause in an update, the update applies to the entire column in the table. So it's very important you use the where clause to prevent errors from happening or to prevent disastrous situations. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres delete statement to delete rows of a table. So if you wanted to remove a record or a row from a table, you need to use the delete command or statement to achieve that. Let's have a look at a typical syntax for a delete statement. So this is how you would structure a statement. You start with the keyword delete, and then you use the from to indicate the name of the table, and then you add a filter with the where condition. When you're deleting records or rows from a table, if you don't use the where condition or where filter, it will wipe out everything from that table. So it's very important to use the where clause to act as a filter to protect other records in the table. So let's have a look at how we'll implement this. I've logged into my PGAdmin 4 tool, and the database I'm going to use to illustrate is the fruits database. This database here, and the table is in the public schema, and the table I'm going to use is this table here called berries. So to make things a lot easier, I'm going to use the built-in script in this PGAdmin to save me time. So I'm going to right click and go script. So different kind of scripts you can use here. I'm just going to say I want to delete, and it will write a delete script for me. All I need to do is make some modifications to that script. So basically it starts with the keyword delete, and then from the schema, and then the table name. This is where you specify the condition. Before you perform a delete, it's always best sometimes to check this table, what's in the table first. So I'll do select star from berries. I'm just going to highlight that and click execute so I can see the data in the table before I make any deletion. So let's say I want to delete this record here called Strawberries UK. The way I will achieve that is in the where condition. I just come here. When you're deleting, make sure you've got the right table. By using the script option from the PGAdmin, it just makes things a lot easier for you. Although you can also manually write that, it just saves you time. So I'm deleting from the berries table, which belongs to the public schema. So I'm deleting where is where I specify the condition. So when you delete, you actually delete a record. A line, all these are all records. So I'm deleting where the berry underscore ID is equals to 1. That is basically the condition. If I didn't have this where clause and I just say delete from public berries, it can wipe out all the records from the table. So you can imagine if you had millions of records or thousands, you wipe them out. So the where clause is very important. What that means, it will only delete records that matches this criteria where the berry ID, berry underscore ID is 1. So let's run that and we can see what it does. Execute. Tells me it's returned, so it's done the job. So if I run this again, there shouldn't be any record for strawberry. All right, so you can see it has record 1 no longer exists, where you've got berry underscore ID 1. It has removed that record from the table. So the process is the same, whether you're deleting 1 record or you're deleting 1,000 records. The key thing to take away here is that you must always use the where clause. If you do not use the where clause when you're deleting, it can cause catastrophic issues by removing records you didn't intend to remove. Very important to specify the where clause in your delete statement. That's it. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to insert new rows into a database table using the insert command. Sometimes when you create a new table in a database, it is bare, it doesn't have any data. In order to add data, you need to use the Postgres insert statement to insert data or rows of data into the table. A typical syntax to insert data or rows into a table is like this. You begin with the insert into clause, followed by the name of the table, and then in parentheses you specify the column names. If the table has got 2 columns, you specify the 2 columns, and then you add the values. The values basically is where you specify the data you're trying to insert, and the values must match the column and also in the order. So these are the columns you want to insert data or row into. You specify that first, and then in the values you have to separate each of the values by a comma. The value list must be in the same order as the column list specified after the table name, which is this one. So if I've got column 1, which is an integer, column 2, which is a string, in the value list it must correspond or must match, must be in the same order. I can't have a data type here of integer and then here I have a data type of string. It will not work. So the format, the column names and the values you enter must match. If this is an integer, the value I'm entering here must reflect that, and so on. When you're inserting or adding rows to a table, you can add 1 row at a time, or you can insert multiple values. So let's see how this works. So I've logged into my PG4 admin tool. I'm going to expand the databases. I've got 3 databases here. The database I'm going to use is the fruits database. And if I go to the schema here, within the schema I've got a public schema, and then I've got the tables. This database has got 2 tables, oranges and berries. So I want to insert some rows, some data into the berries table. So what I can do, I'll right click where it's got berries, and then I'll click on the query tool. Okay, I can either do that, or if I want to save time, I can go to scripts and click on insert script. So that will add some of the script for me. All I need to do is make some modifications. So by doing it by the script option, it saves me a bit of time. So it has kindly done the insert for me, so I don't need to add that again. It's also added the public, which is the name of the schema, and then it's added the name of the table, which is berries. So the dot separates the table name from the schema name. And you can see the parentheses here, that's the opening parentheses, and this is the closing parentheses. And you see it's identified the name of my columns. Berry underscore ID is put that in there for me, and berry underscore name is put that in for me. It can't do the values because it doesn't know what values I'm trying to add. So you notice that each of the values have been separated by a comma. So all I need to do, I know that berry ID is an integer, so it must take a number. So I'll put number 1 there. If I put anything other than a number, it will not work because I'm trying to enter the wrong data type into a column that does not accept a non-integer data type. And in here, if I do the same, if I enter an integer, it will complain. So what I need to do is enter the correct data type. So I'm going to type in strawberry. And do that. Because it's a string, I need to enclose the values in quotes. And then you end that with a semicolon. Now let me execute, and hopefully it should insert the record. If I click on this here, the execute option, and we should see it says query returned successful. So query returned, so it has inserted. So let's quickly check by typing in a quick select statement. So I do select star from berries. Berries is the name of the table, and I execute. Ooh, doesn't like it. Error, duplicate key. Alright, that's worked. The reason I had an error is that because I didn't select this and I was trying to run the query, what it's trying to do was trying to run both queries. It was trying to run this and it was trying to run this. So it was erroring because it thinks I'm trying to add the same data I've already added. So when you have multiple scripts in the editor and you want to execute only a particular one, it's probably best to just highlight that one so the editor doesn't get confused. So as you can see now, I've got a record in our table called berries. That's the ID, that's the name. In some databases, you can set the primary key, or this column here, an ID column, you can set that to auto increase. What that means that you can set up what is known as a sequence. So each time you add a record, it automatically, increases. You don't have to manually add this column. It will auto increase for you. All right, we've learned how to insert a single record, which is what I've done here. So now we're going to insert multiple records. So again, the query is the same. The only difference here is that I've added this to, I'm inserting multiple records. So the values has to match the columns. So I've got berry ID, which is an integer column. So this is the values for that. So I add the berry ID will be this, and the berry name will be that. The second value will be 3, and this will be blueberry. I just need to change the name. I didn't change that. I just changed that to blackberries, and I'll change this to raspberries. Okay, so now if I execute this, I just highlight it. It should insert 3 extra records. Tells you there. Okay, so now I've got 3 extra records inserted. I come here, I run this select statement, I highlight it and click. You can see these are all the records. Now you can see this 1, 2, 3, 4. So that's how you insert records or data into a table. Notice that in production live databases where you have an integer column, normally that is auto populated with a sequence. So you don't necessarily have to manually add this column here. You just add a sequence and the sequence will auto insert the next value for you. So that is it for this lecture on inserting records into a table. Thanks for watching, and bye for now.